Hi. So, hello everyone. My name is Siddharth. My teammate Banu and I were supposed to be here to give this talk today. She unfortunately couldn't make it, so you guys are stuck with me. And I apologize in advance as I ramble, hopefully coherently through the slides that she had. But yeah, we're here to talk to you about the LinkedIn Entity Platform. And this is roughly what the breakdown of what we're going to go through, or what I'm going to go through. I'll give you a bit of background. What do we actually mean by entities within the context of LinkedIn? How these entities were historically both managed and queried, the pain points for application developers across all of that. And I'll walk you through the premise of the platform that we proposed, and then how we went about building it for the first year and a half, the lessons we learned from doing that, the principles that we used that we sort of think worked, and yeah, that's pretty much all we have. So I'll get started. So what's an entity within LinkedIn? I'm assuming everyone here has used the site. What LinkedIn is essentially a digital representation of the global economy, and entities are structured data constructs that are essential components inside that ecosystem. So we have a few examples up here, but so you can think of member profiles, companies, jobs. You can see the sort of magnitude or scale we're talking about for each of those entities. Another way to visualize this is these are essentially nodes in what is a gigantic graph, what LinkedIn likes to term the economic graph. And we provide economic value for our users by allowing them to query across this graph. So you can think of the people you may know feature, for example, is essentially a query across this graph to give you something that you see on your LinkedIn homepage. Another bit of background that is sort of essential for this talk is the fact that we use a microservices architecture. I don't think I need to introduce what that means, but just as a quick sort of overview, each of those entities is essentially its own autonomous service within our ecosystem. So we have hundreds to thousands of entities, and we have hundreds to thousands of microservices within the company. And the idea is that each service is designed to handle a specific entity. It can be developed and deployed independently, and it communicates with other services via lightweight protocols. You can see there. So that's essentially, if you take, again, member profiles, that means there's a member profile service that stores data in a member profiles database. And if you want member profiles, you need to go and talk to that service. So let's talk through what adding a new entity and managing a new entity within the company look like. So for purposes of example, we can think through the certification entity. If you complete a course on LinkedIn Learning or your favorite online learning platform, you get a certificate, you want to put it on your LinkedIn profile. It has a bunch of metadata associated with it. So as an application developer who's trying to introduce this entity, you'd first need to provision a database. So this comes with a bunch of options. Do I use a NoSQL database? Do I use a SQL database? How do I want to do my schema management? How do I capture relationships with other entities within the ecosystem? Once you've thought through all of that, you then need to go build your service layer for your online consumers. So at this point, you usually have a storage API that you want to translate into a more crisp service API. And so a lot of that custom application logic goes into the service layer, and then there's your REST or RPC scaffolding. So bunch of application logic, bunch of scaffolding. Your service layer, before you can actually productionize it, you then need to you have a lot of data platforms that you need to integrate. So this is for compliant access. You need to annotate your metadata. You need to annotate your schemas with certain metadata. You need to integrate with the privacy platform to actually make sure that all query paths could have this compliant access pattern. You need to integrate with the ACL platform for rule-based access control, make sure that make sure sane usage patterns within the company. And then there's the Quota platform for, in most multi-tenant services, just keeping clients isolated from each other and making sure your service can scale. You then need to provision offline pipelines for your offline consumers, any offline views that you require for offline processing. The same thing on the nearline side. Any streaming transformations require you to provision nearline ETLs. And then finally, you have the DevOps aspect of it all. So everything within that little box, you need some amount of dedicated resources on your team for DevOps. OK, so All of that is how you would introduce a new entity. How would I query this entity? So say I wanted to write this query. I want to find all my connections with a specific certification. So as an application developer, you can assume that they're trying to build a new feature on the site that has this data. First thing you would do is go to a service catalog, identify the services serving connections and certifications. Note that this isn't looking for entities. This isn't an entity catalog. It's literally the services of the company. So you're going to go and try, amongst the thousands of microservices that exist within the company, you're trying to find the few that actually you need for you to run your query. After that, there comes a lot of talking to people. So you need to make sure that for the entities that you care about or the services that you identified, do they expose all the APIs that you actually care about? So in my example, can I look up connections by a specific member ID? Can I look up certifications by a certain certification? At this point, you also have a bunch of ways in which you can write this query. So say I just want to look up, I can write this query just by looking up all of the viewer's connections, all of the certifications for a specific certification, all of the members, sorry, for a specific certification, and then doing the join in my application code. That sounds terrible. You have tens of thousands of connections, hundreds of thousands of members who have a specific certification, but it's something that you can do. You can also index these two data sets within an in-house platform like a graph database offering that we have within the company. So you need to build the pipelines to index these entities into that platform and then write a query over that. That query could look like GraphQL. It could look like a Prolog-based equivalent for RDF triples in a native graph database store. All of this is to say that you need to write a bunch of code at this point. So at LinkedIn is a Java shop. Like I said, when you're writing imperative queries over this, you write a bunch of Java code. If you're writing stuff over the graph database, it's, again, GraphQL or Prolog, but there's a lot of code to write, and there's a lot of different ways to write it. And finally, when that query is actually done, you need to figure out all of the client sides of the services that you need to integrate with for compliant access. So get ACLs, get quotas, et cetera, et cetera. So all of this is to say that provisioning new entities within the company took months to get to production. Provisioning new queries or writing new queries for simple applications still took weeks to get to production. And herein lies the premise of a platform. It's fairly simple. Can we get to days to productionize new entities? Can we get to hours to productionize new queries? And so I'll talk you through the high-level idea that we had to make this happen and what actually constitutes our platform. So the first part of it, the part of the platform that handles entity management, is basically taking everything within that box and just abstracting it away from our users. So as a person trying to introduce a new entity in the company, all you really care about is your schema. You want to define the schema of your entity in your favorite schema modeling language. Have some annotations for metadata for compliance reasons, and then declaratively define some configurations. That's about all you care about. Everything else should be handled by a managed entity service. It should pick the best database that you need for it. It should build out the service scaffolding. It should automate all of the creations of offline and nearline pipelines. And it should be a hosted platform that actually does DevOps for you, so that as an application developer, you don't need to get into this turmoil of taking on DevOps when you're just trying to introduce a new entity into the company. On the query side of things, there's a couple of angles of this. The first one is developing a global entity index. So we want a single platform that indexes all entities with easy discoverability. So I've represented this as something that consumes a change data capture from an existing entity. This could be true for any entity at the company. And we'll talk a little bit more about how that breaks down. On the other side of things, as a query author, you just really want to write a declarative query. I don't want to have to imperatively define exactly how everything runs. So just let me write a declarative query for the entities I care about that I can easily discover, and let the platform take care of the rest. So I'll break that down as we go through this, but let's just talk about building the platform. So the first 6 months. We had a small Tiger team. We had 3 engineers who basically, the first thing we did is collect stories from clients and about the pain points that they had while they were trying to do this. Look at look at prior efforts that have been made to try and fix this problem, as well as what's happening externally outside of the company and open source as ways to alleviate these sorts of issues. As part of this, something that actually was surprisingly critical was building buy-in from all stakeholders, and it's actually something that I think, even through talks that I've been attending today, that people attest is something that is hard but essential. So we were able to sit down, we were able to build a POC that works end-to-end and use that to build buy-in from leadership as well as stakeholders, get everyone on the same page that this is something that will be useful and will actually save us a lot of developer hours. Through all of this, one thing that sort of stood out is that we need to show value fast. So we can't, so there were previous attempts to fix this within the company, but it always took the form of a set of people going away for a year and trying to build something that you would only see progress from at the end of that year. In between, clients have sort of no visibility into updates, no visibility into progress, and it's a lot of lift and shift after a year for you to onboard onto these newer offerings. So we wanted to avoid that. We wanted to show incremental progress. And one of the key decisions that we made in this vein was to actually split our project into two parts. So I defined the managed entity offering as well as the indexed offering. And so we decided to first implement the indexed offering. And this means that we'll build this global index over all entities and enable rich queryability. So this includes an entity doesn't need to switch to our managed offering to be part of this index. It could exist in the stack that it always existed in. And we'll just give you a sort of declarative set of configurations that you need to write. And after that, it's one-shot onboarded onto this global index. And I'll talk you through a little bit more about the architecture there. Once this was done, and once we had gathered some experience with running this in production, we would then build out the managed entity experience. So month 6 to 12. We had our V1 release here, and for that V1 release, we identified a single MVP, 2 entities within the company, 200 QPS, get it to production, build everything that we need for that MVP, and build it in a generic manner. So this is where I can sort of talk through the components of the entity index that we built. It's very simple, similar to any sort of platform that you probably thought about. We have a control plane and a data plane. So as an entity within the company, you can have this declarative set of configurations that registers your entity in our control plane, and that governs the data plane experience. So once you do this, basically, I'll talk through the indexing pipeline first. So once these configurations were registered, our control plane would use this to automatically provision an ETL pipeline from the entity into our indexing layer via a transformation service that we built. The indexing layer itself is generic and pluggable, so you can actually plug in a variety of indexes. What we built for this V1 service was a distributed SQL index. And so this means that everything that goes in from all of these entities are essentially tables in a distributed SQL index based on the configurations that you specified that live alongside your entity. On the query side, these configurations that are registered would generate a statically typed API surface that was available to clients. And herein lies the declarative querying experience. So I believe Ent is incubating in CNCF right now, and our philosophy was very similar to Ent, which is from your schema, we want to generate this API surface, generate it in a fluent, and generate a code such that it is a fluent API for all developers. This means you go to your IDE, you write a bunch of, you just, from your entry point, you get a bunch of code auto-completion that is very intuitive to you. And any mistakes that you make or any issues that you run into are caught at build time. So if I'm interpreting a member URN as a company URN by mistake, this is something that you catch at build time instead of runtime, which was a very powerful concept. Yeah. All right, so one aspect that we also prioritized during this speed is prioritizing UX for all of the personas involved. This was, again, an issue that had gone into previous iterations of building platforms within the company, and something we decided to prioritize as a primitive. So we have 3 distinct personas within this. We have platform owners, entity owners, and query authors. One thing that made user experience great for all 3 of these, honestly, is just automation. So we never said a feature was done unless it was automated end to end. For example, when you wanted to onboard an entity, there's a state machine that transitions this entity between various states. The first version of this was just clicking buttons as we sanity checked it within states. This is definitely not scalable. And so we didn't consider this complete until it was automated. The other part, which was useful for actually everyone, but surprisingly for us as well as platform owners, was we built a UI. And this UI contained a variety of data. So for every entity on our platform, it showed where it was inside of the state machine. It gave you links to dashboards, to the specific containers that were running them. From queries, it showed you a breakdown of what the AST looked like from a query perspective, what we had the SQL query that we had translated into, links to performance specific to that query. And it's just a bunch of stuff that made it very useful for us to track entities as well as queries from the platform owner's perspective as well. From the entity owner's perspective, I touched on this a little, but having declarative configurations as your only touch point, and then having a UI to go to where you can just see the state machine move as you've onboarded onto the platform was super useful. Earlier after hours of this, you just have to wait until someone comes and tells you, hey, you're now ready to query your entity, which is not great. And something similar for the query author stories as well. One nice thing when you write a new query onto this platform, it's automatically registered. It shows up on this platform, and it shows up on the UI. And you can just click on links to get associated SLOs. You can see what the performance is, what your latencies are, and everything is very intuitive. Yeah, so the last 6 months I'll cover is where we basically scaled this experience. So this is where we went from 2 indexed entities to 30 indexed entities, 200 QPS to 400,000 QPS, and we started building out the managed entity experience. So I'll talk through just one specific principle that helped us actually scale from 200 to 400,000 in 6 months, which was we really tried to incentivize adoption. When you work at a large company, I think adopting new technologies or adopting new platforms essentially comes as a chore. You're told to do this, and that's why you do it. We didn't want to go down that vein, and so we really wanted to incentivize people to adopt us. One way with this is instead of asking them to write code, we sort of automated and sent them PRs, and we just had conversations on PRs. So we're not going through an RFC, we're not going to talk about this for 2 hours before we decide whether to do this, and you have to identify resources in order to do this migration. You have a PR, and we sort of make our case on the PR as to the benefits you get from this and how this will help you. A bunch of other stuff. So in those 6 months, there were about 4 other major migrations that were happening within LinkedIn. So we were unveiling a new privacy platform for DMA. We were migrating from an in-house metrics ecosystem into open telemetry, and a couple others actually. So yeah, so we were unveiling a new in-house quotas platform that everyone was trying to onboard onto. So if you are as a standard owner of queries, you would have to do all of these one by one, and all of them come with a bunch of pain. Or you could just align with us on the PR, make sure everything makes sense to you, make sure your developers know what happens, and then you get all of that out of the box for free. So this really incentivized people to actually adopt us, and without a lot of strife. Yeah. OK, I think this is the last major slide we have, but I just wanted to talk through this concept of mutually beneficial partnerships that we had throughout the 3 phases that I spoke about. So as a platform owner, we had client partners. Client partners would often come to us and say that, hey, can you build this feature that we need? So there's 2 answers to that. One is, can this be made a generic feature that benefits other clients as well? If not, we probably need to talk about how this can be handled in a more composable way. Like, can you use part of our functionality and then have this really specific functionality that you need outside of our platform? If it makes sense to actually be part of a generic feature on our platform. We actually use resources from our client teams to come to onboard them onto our team for a few weeks, and then help us build out this functionality, which was, I think, a great experience for everyone involved. They got their functionality out of this, and we got the basics of a generic feature out of it. Same thing sort of applies on the infra side. So I mentioned that we had a distributed SQL index. LinkedIn was productionizing distributed SQL for other reasons at the same time. But we weren't quite there for our use case as we wanted to go live. So we embedded with the infrastructure teams, and we helped productionize this distributed SQL database for our purposes. And then we sort of handed it off back to the infrastructure team for them to continue building out the extensive other set of features that they need for a GA launch within the company. And then finally, there's peer platform owners. So I mentioned that we built this declarative API mechanism that is basically fluent and type safe. Turns out that the software development experience inside of LinkedIn was trying to build this out for all services. So instead of you writing custom gRPC stubs for you to query stuff, or custom RESTly equivalents of stubs for you to query things from the RESTly APIs, they wanted to build a declarative way for clients to do this with auto completion and static, the same sort of goodness, static typing, build time, compile time verifications, et cetera, et cetera. So we actually worked with them to have our query API as a single vertical within their entire fan out. And so everyone at the company just needs to adopt a single client, and with that, they can query any service within the company, any REST endpoint within the company, or the entity index. And all of this is sort of more intuitive for developers to use. So today, just to wrap up, we're at about 1.8 million QPS across both indexed and managed offerings. We're at up to about 8 managed entities within the company and growing. And we recently just onboarded the graph database I mentioned as a new indexing system within our layer, so that now we can make cost-performance trade-offs. So if someone is willing to, if someone requires a more performant query and is willing to foot the bill for something that is, that comes with an in-memory graph database, that's abstracted away from them, and all they need to do is just annotate a single configuration that sort of gives us this as a hint, and we'll route it to the correct indexing layer. Yeah, that's pretty much all I had, so thank you.
Thanks, Siddharth. So I think we've maybe got time for one question. Does anyone have a question for Siddharth?
Hi, a great talk. I remember in the initial system before you made this migration, there was like a privacy service and like RBAC. I was wondering how that worked if everything's in one central service, if you still maintain like individual control over that for each entity. So
so your question is, how did it change before and after, right? How did the client experience change before and after? So one of the things that the privacy, and both of them have separate answers, so I'll talk about the privacy platform, but basically it was a new API integration that needed to go into every set of application code at your gRPC layer. You basically needed to call into a specific API, and then you needed to set up some configurations on the platform for that API call. Turns out if you're just going to send index queries, you're going to just query this global, if that query that you were writing could just be a global entity index query, you don't need to worry about all of that. We've already integrated all queries on our end with that entity, with the privacy platform. And so that's something you don't even need to think about. So that was how it worked for the privacy platform. For the ACL platform, the story is, the benefits are slightly less in that you still need to go in and click a couple of buttons to actually provision correct ACLs. But the way that we did it is, basically, when you write your query, a bunch of this is auto-provisioned off the bat with sort of limited and temporary quotas as well as temporary access control. And then you could experiment with it a little bit, and then only click those buttons when you want to productionize your query. If you want to throw it away, no harm, no foul, we'll just garbage collect after a while. So there's slight benefits there. Yeah.
Super. I think that's time. So thank you very much, Siddharth.
Thank you.